sets and elements. Now let's talk about some of the common universal sets that are used in mathematics. A universal set is a set that contains all possible elements and sets. The letter U is frequently used to notate a universal set. A common way to demonstrate a universal set is with a Venn diagram. In this case, we have two overlapping circles representing sets A and B. Notice that the universal set contains everything in the entire diagram and includes sets A and B, as well as all elements that are not contained in sets A or B. There are several common universal sets that we will use in these videos. The natural numbers are the basic whole numbers that people use when they learn to count, like 1, 2, 3, and so on. Some definitions of natural numbers do not include the number 0. For these videos, we will include 0 in the set of natural numbers. The set of natural numbers is notated by a stylized capital N. The set of integers includes the natural numbers, but it also includes negative numbers. The set of integers is notated by Z. If we want to specify only positive integers, we just add a plus sign after the Z. If we want to specify only negative integers, we add a minus sign instead. Remember that 0 is neither a positive nor a negative integer, so it's not included with either the positive nor negative integer sets, but it is included in the set of all integers. So far, all of the sets have included only whole numbers. What if we wanted to add fractions? Fractions are included in the set of rational numbers, which is notated with the letter Q. Now we won't be dealing with rational numbers in these videos, so let's look at the last common universal set that we'll be dealing with, which is the set of real numbers. The set of real numbers includes the previous sets that we mentioned, including rational, irrational numbers, such as pi and Euler's number. It's not easy to represent a continuous set of real numbers. We'll talk more about that in a later video. For now, we'll just use a stylized R to represent real numbers. Now that we know the common sets along with their notation, we can use this to define new sets. For example, we can easily define the set of all even integers. Here we have an x such that x is equal to 2n, where n is an integer. Since any integer multiplied by 2 is even, this defines the set of even numbers. Notice that this is just another way of saying this. If we wanted to define the set of all odd integers, we can just add 1. Twice any integer plus 1 is always odd. This was just an overview of some of the common universal sets. In the next video, we'll introduce complements and subsets.